Hello and welcome to today's math video. In this video, we are going to be correcting your worksheet that it describes a solution to a system of linear equations. So here we have a system. These two equations represent a system, and we want to know, does this ordered pair work? So remember, this is the x value, this is the y value. So in this first equation, in place of x, I'm going to plug a 2, and in place of y, I'm putting a negative 2, and I want to know, does that equal 4? So if we have 6 plus a negative 2, that equals 4 equals 4. So that ordered pair, 2, negative 2, works for that first equation. So this first one is a yes, it does work for that. So now we have to see, does this ordered pair work for the second equation also? All right, so in place of this x, we're going to put a 2 minus 3, and now in place of y, we're putting a negative 2, and we want to know, does that equal negative 4? So we have 2 and we have negative 3 times negative 2 is plus 6. And does that equal negative 4? And the answer is no, this does not work. So this is not a solution. 2, negative 2 does not work for this system. All right, let's check out the second one. They want to know this time if 3, negative 1 works. So in place of x, I'm putting a 3. And in place of y, I'm putting a negative 1. And we want to know if that equals 5. Well, negative 2 times negative 1 is a positive 2. So we have 3 plus 2 equals 5. And the answer is yes, it does work for that ordered pair. All right, so in place of here, we've got 2 times x minus a negative 1, and does that equal 7? So 2 times 3 is 6, minus a negative is a plus 1, so 7 equals 7. So yes, it works for the second equation also. So this ordered pair works for both of these, so yes, this is a solution. This is a solution. All right, trying this third one here, number 4. Remember that this is x and this is y. So I'm just going to plug it into this equation for space purposes. So 2 times negative 1 plus 3 times 5. And we want to know, does that equal 13? So 2 times negative 1 is negative 2 plus 15. So 13 equals 13. So yes, it works for the second equation. Okay, how about that first one? If we have, and here we have a minus, and then we have to put that number in. So this is minus a negative 1 plus 5. Does that equal 6? Well, minus the negative 1 is 1 plus 5. So 6 equals 6. So it works for this first one too. So number 4, yes, it is a solution. All right. In our next one here, so the same thing. So we had 6 problems as far as homework. So I don't really have a lot of room here for as much work as I want to do. So I might have to erase and then go on. So this is x and this is y. So in place of x, I put a 1, and then we have negative 2 times negative 4, and does that equal 8? So we have negative 2 times negative 4, so we have 1 plus 8, and does that equal 8? Well, the answer is no, because 1 plus 8 is 9. So no, this did not work, so not a solution. Okay, if it didn't work for the first one, it could potentially work for the second one, but at any rate, those two lines will not be meeting at that point. All right, let's go on to number 10. So this is x, this is y. So in place of x, I'm putting a -2. So 2 times -2 minus 3 times 1. And we want to know if that equals -7. So we have -2, 2 times -2 is -4. -3 times 1 is -3. So yes, -7 equals -7. So yes, that ordered pair works for the first equation. Okay, does it work for the second one? So we have 3 times -2 plus 1. So 3 times -2 is -6 plus 1. And we get -5, and we had a -5. So yes, it works here. So -2, 1 is a solution. That ordered pair works for both of those equations. All right, on to the last one that we have here. So this is x, this is y. So in place of x, I'm putting a 5, and in place of y, I'm putting a 2. So 5 times 2 is 10 plus 2, so 12 equals 12. All right, and then in the second, so yes, it absolutely worked here. So let's put it in the next one. So we're putting in a 5. -3 times 5 is -15. Subtract 2, and do we get -11? Well, -15 minus 2 is a -17. And a -17 is not the same thing as -11, so it's no. So the last problem here is not a solution. All right, I hope this helps on figuring things out.